for the last 50 years, any reader of ancient Egyptian history has been told that the ancients called their country Kemet, which supposedly means black land, or literally black land, as they say. This translation rests explicitly on the presumption that the term black land refers to the agriculturally fertile black alluvial soil deposited along the Nile River. Yet 125 years ago, that claim that the Nile banks are filled with alluvial black soil would have been absurd to a young British soldier and future prime minister named Winston Churchill. Churchill makes an apparently non-controversial observation in his book, The River War, published in 1899, that the soil is red. To resolve the obvious contradiction, black soil versus red soil, this presentation turns to the geological record to understand the underlying conditions that are responsible for the formation of the Nile River and the vast Nile Basin, and how those conditions manifest themselves today in the resulting rock formations and in the soil. Now, what does the research actually reveal? The monsoon season in the Ethiopian Highlands is responsible for 85% of the water and sediment that comes to Egypt. The iron ore embedded in the ancient basalt rock formations of the Ethiopian Highlands is exposed to the monsoon's rainwater and the open air. Now, this chemical reaction, iron plus moisture plus air, produces a layer of sediment, a layer of red to reddish-brown dehydrated iron oxide, commonly known as rust, that builds on the rock in the off-season. During the following monsoon season, this red to reddish-brown rust is the sediment that is washed off the rocks and carried down the mountains by the rainwater via the Blue Nile and the Atbar River, which join the White Nile before entering Egypt. You'll hear today an interpretation of an ancient Egyptian myth that confirms that the ancients understood this soil to be reddish in color and its importance to the country's agricultural success. And we'll consider for re-examination perhaps two presumptions made fact that depend on the black land equal black soil motif. Their continued validity is also equal to re-examination as the black soil motif itself. So let's begin with the definition of alluvial soil. Essentially, what makes soil alluvial is that it is brought to its current place of deposit by a river that picks up sediment from another location. Where the sediment deposited along the Nile River comes from is the subject we're here today to discuss. How is soil formed? Well, geologists agree that soil is essentially weathered and eroded rock as a result of cyclical mountain formation, erosion, and sediment deposition over long periods of time. Colin Reeder engineering geologist by profession and author of a gift of geology, says that to understand the Egyptian landscape's evolution, the evidence is in the soils and the rocks. So we know that soil composition is not disconnected from the geologic record. And the geologic record spans not decades, centuries, nor millennia. It's millions, billions of years. Now, while Reeder focuses on Egypt in this commentary, the same can be said of Ethiopia's rocks and soil. The main composition of rock and soil that we're going to focus on today is in Ethiopia, volcanic rock, or as it is called, basalt. And in Ethiopia, volcanic rock or basalt is dominant, so much so that the presence of basalt is twice that of granite. So why focus on Ethiopia? The Blue Nile originates at Lake Tana, Ethiopia. Most of the water and sediment flowing from through the main Nile is from the Lake Tana region, 85% of the total flow. And the country's exposed volcanic rock, the basalt, contains iron. The importance of the Blue Nile as a highway for the nutrient subsidy provided to Egypt cannot be overstated. You cannot overstate it. Douglas Brewer, an anthropologist, and Emily Teeter, an Egyptologist, contribute one of the most important myth-shattering bits of Nile River information concerning its role, the Nile River's role in Egyptian agriculture, yet it has received very little attention. They say during August, the Nile River rose rapidly and its waters assumed a muddy red color because of the presence of rich red earth brought into the Nile by the Blue Nile and the Adbar. Now it's notable that the authors use the present tense here, the past tense, They reveal their intentions in the same paragraph, and this is produced right here, reproduced right here. If today's floods were not controlled by the series of dams, the inundation would be approximately the same as it was in dynastic times. In other words, in a time span of 5,000 years, the characteristics of the Nile River and the Nile Basin have not been changed substantially, other than that the river for the now rarely if ever overflows the banks of the Sudanese or the Egyptian Nile, since the dams act as flood controls and also power generating. To emphasize the point a bit more clearly, or directly, if the soil is red to reddish-brown, now it possesses the same color scheme in pharaonic times. It was red to reddish-brown back then. The significance of the Brewer and Teeter commentary above seems to have been lost in Egyptologists. Brewer and Teeter's work leaves no room for a black soil theory to dominate how we understand the riverine landscape of the Nile Valley, particularly its geologic and its alluvial history. Their 2007 book is perhaps a watershed event, though over 15 years earlier than that publication, we actually had a partial disclosure in another publication that red mud reaches the Nile Valley, Nile banks. Hopefully someone will ask me to elaborate on that in the Q&A period. You won't be disappointed. Based on the additional evidence that we're about to see shortly, the following question inevitably must be asked. How can Egypt's alluvial soil be any different than that of its Ethiopian benefactor? As we'll see, it cannot. Martin Williams, a geologist from Australia, in his book, The Nile Basin, provides a powerful explanation why the rain-weathered soils washing down from the Ethiopian highlands tend to be reddish in color. He says, by far the most fertile soils in the Nile Basin are those derived from volcanic rock. The Ethiopian headwaters of Blue Nile and the Adbar rise amidst the basaltic lava flows of the Ethiopian highlands in well-drained sites. The basaltic soils are well aerated and the iron content sufficiently well oxidized to give rise to the vivid red clay soils. These soils are widespread in the Ethiopian highlands and are easily eroded during the intense rainstorms of the monsoon season, bringing silt and clay to the lowlands of central Sudan and the floodplains of the Blue Nile, Adbar, and main Nile. Sometimes pictures are worth 1,000 words. Let's explore the landscape of Ethiopia, in the Ethiopian highlands, specifically in the Lake Tana region. All right. And we'll begin with some satellite photos of the Lake Tana region. Satellite photos. And we'll use this chart right here to help guide us, to show how the surface of the Lake Tana region turns a reddish color after the season of significant rainfall. Note here, when you see this, that each time you see one, this is December 31st of 2002, so everyone you see is December 31st, the off season, okay? Now, going back here for a second, notice how you have drought conditions for most of the aughts, right? 2000, all the way to 2010. So notice in 2001, you see high rainfall. So when you first see, but you'll see how the high rainfall then picks up later. Notice how you'll see right now that it's a little reddish, right? This is 2002, so 2001 had an impact on the amount of sediment deposited along the surface of Lake Tana. This is 50,000 square miles that you're looking at. So when you pay to what you need to pay attention to as well, and I'm hoping that I can get this to work. I don't think I'm going to get that to work. Let me show you. Pay attention in particular to these mountainous regions here. Right, mountains, you'll see the color changes. Again, we're talking 50,000 square miles, so that's a lot. Let's go 2002, 2004. All right, we're into the drought now. 6, 8, 10, 12. Watch now. 14, 16, 18, 20. Let's go one more and a little close up. Now, what we're looking at here is the southern end of basically of Lake Tana. But notice at the bottom here it's called Bahir Dar, right where it sort of leaves. That's Bahir Dar. That is the city located right next to Lake Tana. And that is the beginning of the Blue Nile. So when Lake Tana overflows, where does the Lake Tana overflow come out? It comes out of Bahir Dar. That's the beginning of the Blue Nile, okay? Now, we're gonna look at Bahir Dar now at ground level. So if you can see, it's maybe hard to see, but that water, it's actually reddish-brown, a little reddish-brown. Here we go. Look at the brownish in the water, look at the soil. Oh, we just getting started. Okay? Now, I like this one right here in particular. This is one vision. Now, see, same view, different time period. Look at the water, though. Look at the muddy red color. Look at that muddy red color. Look at the muddy red color, not only of the water, but also of the dirt, the soil around it. Does that look like black soil to you? Black, fertile, whatever they want to call it? Does that look like, that looks reddish? Same here for that one, right? Okay, so this is Bahir Dar. Now, we're going to travel 300 miles. Well, we're going to travel, and eventually we're going to end up 300 miles away. Before I do this, guys, let's see that. Look at the color. This is the Blue Nile. So when we were here, right, at Bahir Dar, that's the start of the Blue Nile. So this is what's coming out of Lake Tana region, the Blue Nile. Not only the Lake Tana itself, but the mountainside. We'll get to that. That's very important. The mountainside contributes as well, because it's like a catchment. When it starts running down the mountain, the Blue Nile comes right by and sweeps everything in. Okay? Now, this right here is the Grand Ethiopian Renaissance Dam. This is 300 miles along the Blue Nile from Lake Tana. So you're dropping 3,000 feet in 300 miles. That's a pretty steep drop. That's one picture of the Renaissance Dam. There's another. Again, focus on the color. This is sediment that's in there. This is what we're talking about, the reddish soil. This is only 10 miles from, roughly 10 miles from the Ethiopian-Sudan border. So that means what you see right here is getting ready to get to Sudan. And then what's it going to do? Get to where? Egypt. As I said before, how could Egypt's alluvial soil be any different in color than its Ethiopian benefactor? As we see, it cannot. Look at the banks. Look at those banks. That's soil. Look at that right there. This is the Egyptian Nile.